Hello and welcome to Source to Code, your magic decoder ring to demystify the jargon surrounding the technology industry. I'm your host, Ben Coffin, and join me each week as I try to dig into what these buzzwords are all about, how they're being used, and who actually needs them. We're cruising on through Season 1 and on to our second to last buzzword for the season, big data. Data can sometimes feel like the buzzword to end all buzzwords because it's the language we use to talk about anything from your personal identity on the internet all the way to the specs and characteristics of your car, your house, even your pet's activity. Data is the currency of the modern age, allowing us all to exchange data for virtual services, free-to-use apps, and any digital assets that we might be after. And we know data is precious too. We've got to secure our own personal data, our corporate data. We want the cloud where our data is stored to be safe and secure. And we've all learned to be responsible with who we give our data to and who we don't. When we talk about data, though, we know it's getting consumed somewhere. So where does our data go? What do companies do with the data they make? And how is their data used? These are the questions that we're trying to unpack as we demystify big data. So we're going to look across the next 3 episodes at how companies are using data practically and what it takes to make data matter. We'll start in the lab, then move to the world of production, and then end up looking at the infrastructure of data usage and how it comes all the way back around full circle. In today's episode, we're back on the road. Electric vehicles make up almost 10% of global car sales, and the process of building those cars is changing the fabric of the automotive industry. With the transition to electric motors, driver-assisted and autonomous functionality, and bigger and badder batteries that can hold up to these demands, the development workflows for this whole ecosystem are changing. We covered how digital twins are making an impact in last week's episode, which, if you missed it, head on over to keysight.com/find/source-to-code. But digital twins both require and generate massive amounts of data. So when we're in the development workflow, how does the data get generated and how does it get used downstream? To get to the bottom of this, I sat down with Albert Groebmeyer, strategic portfolio planner for battery cell test solutions at Keysight. We'll be right back with my conversation with Albert right after this. Organizations across multiple industries are turning to 5G private networks to accelerate digital transformation and improve productivity, efficiency, security, and safety. To stay in the loop, Keysight's created a 5G private network content hub to be your comprehensive repository of information and resources to start your organization's private 5G journey. You can find the private network content hub at learn.keysight.com/5G-private-networks. Or head on over to Keysight University, where you can find the hub under the Networks and Apps tab. Jump into Private 5G with Keysight at the Private Network Content Hub today. Well, thank you, Albert, so much for joining me to talk with me today on Source to Code. So we're talking about big data today, and we are looking at the different ways in which we take data in sort of the testing process and how we actually utilize it and sort of what the value of capturing all of this data is. So I know you work in the battery space for electric vehicles. So maybe to start off, let's talk about maybe what kind of data we're dealing with when we look at this process. So when these companies developing electric vehicle batteries are developing a battery cell or a battery system. In those early design stages, what are the types of data that they're collecting, and what are we looking at?
Okay, Ben, yeah, it already starts with the materials. So designing a battery cell and then developing it, it's a process which really creates a lot of data. And it all starts with the materials. You have a lot of different components and compounds which are needed to build a battery cell. And it all starts with the suppliers of these materials, which will hand you over a lot of different parameters of these materials, how they were produced, what are the typical characterization, what are the typical characteristics of these materials. And These information you will receive, and then from that you are starting to produce a lot of own data.
Mm,
So when processing these materials, you will create a lot of new kind of data, because you have a lot of data created on machine level, which will be created by starting from the mixing process, later on how the electrode is manufactured. So you will get a lot of information just out of that processing of materials. Later on, you will have a lot of information you will receive during the assembly, which also includes factors like temperature or humidity,
mm,
some parameters which are important uh, for the manufacturing of cells, but you will get them just from the environment in the test setup. And later on, when the cell is completely assembled, then really starts with the electrochemical data. You will receive a lot of a lot of new data from the cell based on current, based on voltage, and all
mm.
the things you can just get out of that. It's like the capacity of the cell, the fast charging capability, the resistance of a cell during a test, and all these data you can use for your development.
Okay, so we're talking about a lot of data right out the gate. It sounds like there are a ton of variables in a single equation for a design, and there's just there's tons to be aggregated. So when we talk about capturing that data, look at it for maybe a single device or maybe a device through its sort of design life cycle. How much of that data is captured, and how does a company use that as they keep going through? We can start to collect this, and maybe we've logged it, but how do they actually use that data?
Yes, it's very easy to create that data and to track that. That's true, because the space doesn't really cost a lot. But then the real works really starts. You have all these information, and you're doing a lot of investigations. You're changing parameters all the time. But since you're creating such a huge amount of data, it's really hard just to change one parameter once at a time. So you really have to change a lot of these parameters at at the same time, and see the
Mm,
outcome of the cell, and therefore you need to do a huge analysis of a huge data set. So it's absolutely necessary that you really dive deep into these huge data lake, so that you can get all the information out which are important. So the data analysis is super important, and it's really important that you have the right tools to do so. And
mhm,
in best case, you also have some kind of data analytics, which really helps you to identify outliners and identify correlations between different parameters. Sometimes there can be a parameter which is just because of the processing of the material, which has a huge impact on the electrochemical performance. And then sometimes there are some other correlations which are really hard to identify in the beginning, since you have a huge amount of data. But as soon as you get a deeper insight into that, you can find this correlation, and it can really accelerate the development of your R&D project. So it really takes a
mhm.
long time to produce such a cell and bring your materials into the right shape, and bring the cell into the right condition, so that it can be applied in an electric vehicle later on.
Yeah, and it's interesting. It seems that the because of the need for sort of I guess need for speed in the development process, and as we see the time to market for products having to increase constantly, it makes perfect sense that you have to change multiple variables at once, and then figuring out how that all sort of correlates back is definitely a challenge. So what we're this company, we've built this data lake. We're trying to now sort of get those insights and those analytics there. What kind of constraints are on that process? You mentioned tools being a factor of it, and being able to have tools that allow you to get insights into data. What else are we dealing with when we're talking about these constraints around all this data we've generated?
Of course, it's time. Um, so you have a huge pressure right now on the cell manufacturers and the car manufacturers to bring their products out to the market as soon as possible. And it's really important that you really identify these correlations very early, so which will allow you to build a better cell and then also a better battery pack for your electric vehicle. And that's really constraining. So you have a limited amount of resources. Yet you cannot hire hundreds of engineers just to find these right parameters to produce the best cell you can get. And then on the other hand, you also have to think about the cost perspective. So time is super important to optimize the project. But yeah, on the other hand, since you're changing so many parameters all the time, you have to be sure that there's really a correlation between those parameters as you think of, because you might can fall into a trap here, yeah, in that case, you will just delay your R&D project, and you have to really be sure. And therefore, it's also necessary to have a lot of test capabilities.
Hmm.
Yeah, just to make sure that you are developing the right cell at the right time.
Yeah, I can imagine that finding a correlation sometimes can lead you on down the wrong path, right? Where you're looking at the data and you have to be able to trust that data, right? I think that there's maybe a that's the relationship between the amount of data that you capture and then actual insight that you want to take from it, right? And so there's an interesting relationship there where, yeah, you have to have the right tools and processes and have got the right information in the first place to actually be able to do anything with it and trust it.
Yeah, absolutely. You have to trust the information you receive from your suppliers. You have to trust your data tracking. So whenever you
Mhm.
produce your cell, you have to make sure that you really get the right data. And of course, you need precise measurement instruments here that you will really get the correlations out of that. If just in case you have inaccurate measurement devices, which will lead you to a wrong path here. So that's super critical.
So we talk about sort of the pitfalls of this, and obviously, if you go down that wrong path, okay, there's time to market concerns, and I totally understand that. There are tons of these new electric vehicles that I've got my eye on, and I can't wait for them to be available and be able to maybe someday get one of them. But beyond just the time to market aspect of it, for the end customer, for the people that are, you know buying electric vehicles now, what can they take away from this process of, hey, as this thing is being created, it's generating monstrous amounts of data, and there's insights and analytics, like how do we connect that back to what the end customer of the vehicle actually experiences?
Okay, at first, you can be sure that you will receive a product which was developed in a very well documented way.
Mm,
So that's the first thing. And during the production, it's the same. Not only during the R&D development, everything's tracked. So everything, the speed of a machine, the pressure which is applied on the
mm,
material, the humidity, as I said, so everything's tracked. And whenever there's some kind of defect identified, it can, be identification coming from the supplier that material batch was not prepared the right way, or later on during the cell assembly something could have gone wrong. And yeah, with all these information, you are able to have the tracking and of the data, and you are able to retrace where these products are coming from,
mm.
and therefore you are able to identify which car might be affected from a defect of maybe one electrode coil here. And
Mm.
therefore you will be contacted by your car manufacturer, and yeah, they will change your battery pack in that case.
Okay. So that's the getting those insights, that tracing is going to lead to being able to maintain safety on the road. You're sure that your car parts are functioning accordingly, and if not, we'll get them out and swap them. For doing recall type scenarios.
Yes, that's super important. So whenever using a cell phone, that's for a very short amount of time, and it's limited to only a few years. But electrical vehicles, they will go for more than a decade. And
Mm.
yeah, with the ongoing time, there's a higher risk for some failures, and which can lead to real safety issues here. Sometimes there can be fires that the battery is self-igniting, or during a charging process that one of the cells ignite themselves. And therefore, it's super important that you make sure that you have the best product out, and everything what can be excluded is excluded here.
Yeah, absolutely. So at the end of the day, we're really looking at not only the ability to trust data, but that trust in data and being able to get to a point where we can do that is trust in the electric vehicle battery itself, right? It's our ability to say, okay, I know my car is going to charge safely and be able to last for a decade plus safely. And so yeah, I think this makes a ton of sense. Well, awesome. Well, Albert, this has been fantastic to get some insight into this whole process. I know the electric vehicle market is obviously a hot place right now. I'm not quite yet on an electric vehicle, but I'm looking forward to switching over. But this definitely gives me some insight on how this all works.
Great, thanks, Ben.
Trust is the big word, it seems, when it comes to data. Can you trust the data that you're getting? Can you trust your analysis of the data? And does that data ultimately help your product instill trust in your customers? The root of everything that Albert and I talked about circled around this idea that data has to be quote unquote good. In our world as a test and measurement company, one of the main things we do is we help customers make sure that they have confidence in the measurement that they're taking. So that means reducing noise in the system, ensuring proper measurement science, and delivering to them data that's pristine. It's unspoiled by that act of observation. Building confidence in your data and being able to track it through the product lifecycle is invaluable to companies developing products or solutions because it means less time spent on fixing bugs or troubleshooting odd behavior. But to the end customer, it means that this product is something that they can put their trust in and will come back to time and time again. If you're now thinking about your entire approach to testing and wondering if you're getting the data that you want, maybe swing on over to keysight.com/find/source to code and check out the white paper companion piece for this week's episode. In the paper, Understanding Measurement Accuracy Specifications for Battery Testers, you can figure out exactly what to look for when evaluating battery test equipment and what pitfalls could lead you astray from that good data. And while you're on our webpage, join our mailing list, where you can get on our feed and stay up to date with what's happening in the world of source to code. Plus, you can be entered for a chance to win a hoodie with a Source Decode logo that will be the perfect companion to some at-home decoding. You can also find that link to join the mailing list in our show notes in your podcast app. Thanks again to Albert for joining me on today's episode, and looking forward to next week where we move out of the lab and into the world of manufacturing and production. Until next time, I'm Ben Coffin, and this is Source Decode.